When factoring trinomials, we are talking about having polynomials in the form ax squared plus bx plus c. So trinomial being three terms, a being the coefficient of x squared, b the coefficient of x, c the constant. So there's typically what we can do is break this trinomial down into two binomials. So we're trying to factor this into two binomials. So we're making it look like something plus or minus something times something plus or minus something. Is how we're trying to break this down. So to do this, what we do first is we look for the combination, find the combination that of two numbers, find the two numbers that multiply to a times c and add up to b. So what we do when we find those two numbers, and then we use these to split bx into these two numbers. Whatever number the first one is x, whatever number the second one is x, and then what we do is we factor by grouping to get our two binomials. Okay, so let's say, I'll keep that up as a reference. So let's say, for example, I have x squared plus 8x plus 15. And I'm going to show this organized with an x. Sometimes this is called the x method. So I'm looking for the number that multiplies to 1 times 15. So if I kind of look at this, a is 1. Oh, don't want that. A is 1. B is 8. And C is 15. So I'm looking for what multiplies to 15 and then what adds up to 8. So the two numbers that multiply to 15 and add up to 8. So if I think of numbers that you multiply to get to 15, 3 and 5 pops into my head first, and 3 plus 5 is 8. Okay, so like I said, now what we're going to do is we're going to split up that 8x into 3x plus 5x. And then the x squared comes down, so this term comes down, 15 comes down, and now I factor by grouping. So if I kind of split up my four terms into the first two and take out an x, I'm left with x plus 3. And then out of the second two, if I take out a 5, I'm left with x plus 3 as well, which is what I want when I do grouping. So my binomial in common, x plus 3, times my leftover stuff, x plus 5. So let's check that out. X times x for my first is x squared. Outer is 5x. I'll jot this down as my check over the side. Outer is 5x, inner is 3x, and then last is 15. There's my check. And 5x and 3x. Yep, that adds up to 8x, so I know this checks out. So there is my answer. Okay, let's do another one. How about x squared minus 10x plus 24? Okay, so A is 1, B is negative 10, and C is 24. So notice now we have a minus sign, so we have to read that as a negative. So 1 times 24, I'm looking for what multiplies to 24 and adds up to negative 10. Multiplies to 24 and adds up to negative 10. So sometimes too, like 24 has a lot of different options, so we can start listing off. 1 and 24, 2 and 12, 3 and 8. Looks like I'm getting closer. But 3 and 8 don't add up or have a difference of 10. 4 and 6. 4 plus 6 is 10. Let's see what the signs now, if that matches up. I would have to do a -4 and a -6 to add up to -10, but -4 times -6, yep, that is 24. So this is my combination. So notice the part that's multiplied. If it's positive, they're either both positive or both negative. But if my adding up to b is negative, that means they're both going to be negative. So I'm going to split this up to a -4x and a -6x. Because that's the same as -10x. I'm just splitting it up. But if I go back up a step and simplify, put those two together, I'm back up to my -10x. Okay, so now if I do my grouping, split this down the middle. First two, they have an x in common. I'm left with x minus 4. Second two, they have 6 in common. It looks like I'm going to have to make it a -6, so my signs match up, and I'm left with x minus 4. So x minus 4, and then x minus 6. FOIL it out. This one checks out too. Okay, how about, I'm going to do another one that starts off just x squared. X squared minus 4x minus 21. So I'm kind of doing different signs here. The first one, positive, positive. The next one, the middle term, the b was a negative and was positive, and we had to multiply to a positive, add up to a negative. They both had to be negative. Now this one, my multiplies, a times c, 1 times -21. I need to multiply to a -21 and then add up to a -4. I'm going to make that a little neater. So multiply to a -21 and add up to a -4. So here, I mean, I'm thinking 3 and 7 is jumping out at me with the 21. To add up to -4, it's going to have to be a +3 and a -7. 3 times -7 is -21. 3 plus -7 is -4. So just like we did before, I'm splitting up the -4x to be 3x and a -7x. So a +3x and a -7x. Bring down the x squared, bring down the -21. So out of the first two, factor out an x, and I'm left with x plus 3. Next two, I'm going to factor out a -7 or -7, and I'm left with x plus 3. So x plus 3, x minus 7. FOIL it out. This one should work out as well. So notice, with that being a minus for the c, one's going to have to be plus, one's going to have to be minus. And really, it's the larger number. It ends up being negative because my middle term was negative. Now when we put a number in front of x squared in a second, that's not always the case. It's not as easy to see, but true when a is 1. One more before we put a number in front of the x squared. X squared minus 5x plus 2. So what multiplies to a times c? 1 times 2. So what multiplies to 2 and adds up to -5? So what multiplies to 2? The only combination is 2 and 1. And there's no way we can add 2 and 1 and get to -5. So if there's no combination that works, we would say that this is not factorable. This one is not factorable. I can't break it down at all. Or sometimes too it's called prime. Just like prime numbers, you can't break them down. Same with polynomials. If you can't break it down, it is considered prime. So next, let's now put a coefficient in front of the x squared. So this one, let's say I've got 3x squared plus 13x plus 4. Okay, so same steps. It's just that now it's not just 1 times whatever c is. Now a is 3, C is 4. So I'm looking for what multiplies to 12 and adds up to 13. So multiplies to 12 and adds up to 13. So this one is going to have to be 1 and 12. 1 times 12 is 12. 1 plus 12 is 13. So I'll split up my 13x into just x, 1x plus 12x. Bring down 3x squared. Bring down plus 4. So when I do my grouping, first two, pull out an x. I'm left with 3x plus 1. Next two, it looks like I can pull out a plus 4. And again, I'm left with 3x plus 1. So 3x plus 1 times x plus 4. Again, always FOIL to check it out. Okay, one more. 10x squared minus 7x minus 6. So I'm looking for what multiplies to 10 times negative 6. 10 times negative 6 is negative 60 and adds up to negative 7. So here's another one that I've got a lot of different possibilities with 60. So sometimes it helps to just underneath make a list. 1 and 60 is not going to work. Doesn't add or subtract. 2 and 30, that's not going to work. 3 and 20, 4 and 15, that's not going to work. How about 5 and 12? So that's a difference of 7. Let's see if that works. 5 and 12. 5 and 12. So one is going to have to be plus, one's going to have to be minus. To get a minus 7, it would have to be negative 7. 5 times negative 12 is negative 60. 5 plus negative 12, yep, that's negative 7. So I got my combination. Positive 5 and a negative 12. So I'll bring down my 10x squared plus 5x minus 12x, bring down the minus 6. One thing I'll point out at this, maybe you've been questioning so far, what if I had switched the negative 12 and the 5? You know, multiplying and adding, that doesn't matter. It would still work if I had a negative 12 and a 5. Same thing here. If I had these switched, you still would come up with the same answer. Basically, in the end, the two binomials would be switched around, but it doesn't matter the order. 2 times 3 is 6. 3 times 2 is still 6. Order doesn't matter. Okay, so out of the first two, if I take out 5x, I'm left with 2x plus 1. Next two, I'm going to take out a minus 6, and I'm left with 2x plus 1. So 2x plus 1 times 5x minus 6. Okay, so that's quite a few examples on factoring trinomials. One thing I will note as well is there are a lot of different ways to do this. This is one method, but you know, if this method didn't work, there's other ways. Trial and error. There's a box method. So just so you're aware, this isn't the only way to solve these.